Assalamualaikum warahmatullahi wabarakatuh. I am your tutor, Natasha Herman. Today we'll be discussing about the techniques of integration. This chapter contains 4 subtopics, which are U substitution, integration by parts, partial fractions, and trigonometric substitution. From this chapter, the students are able to understand and differentiate each techniques of integrations which involves the 4 subtopics. The students get to know the real-life applications involving integration. The definition of U substitution. If U equals to function g is a differentiable function whose range is on interval I and f is continuous, then we can find function u plus c. The idea of using substitution is to simplify the integral. Substitution and the general power rule. If f is a differentiable function of x, then n is not equals to -1. The change of variables for definite integrals. If the function u equals to function g has a continuous derivative on the closed interval ab, which is the limit, and f is continuous on range of g, then we can find the answer through the limit. These are the guidelines for u substitution. If possible, choose u so that u prime x is part of the integrand. Number 2, consider choosing u. We can choose u, the inner function of composite function, the expression inside a radical, the denominator of a fraction, and the exponent of an exponential function. This is one of the examples of u substitution. Integrate 3x squared times x cubed plus 1 to the power of 10 dx. We let u equals to x cubed plus 1, the inner function of composite function. Then we find the du over dx equals to 3x squared. Du equals to 3x squared dx. From the equation, we rearrange the equation back. So 3x squared dx, we can substitute it into du. And then we change it into u. We find the answer 1 over 11 u to the power 11 plus c, and then we change the u back, substitute it back, x cubed plus 1 plus c. Okay, students, all of you can try this equation to solve this problem. The hint is let u equals to 2x squared plus 3. Okay, this one, u equals to 3x squared plus 6 sine x. Okay, for this example, integrate x exponential to the power -2x squared dx. We let u equals to -2x squared, du over dx equals to -4x, du equals to -4x dx, du over 4 equals to x dx. From the equation, we rearrange first. So x dx, we substitute it into du over 4, and then we calculate. We find the answer equals to -1 over 4 exponential -2x squared plus c. These are the exercises that all of you can try, and also this one. That's all from me. Thank you so much and do your best. Assalamualaikum.
Hi, I'm Mia. For today's lesson, we're gonna learn about integration by part. So, what are you waiting for? Let's go into the slide. First of all, what is integration? Okay, integration is a way of adding slices to find the whole. The process of finding integral is called integration. Along with differentiation, integration is a fundamental, essential operation of calculus and serves as a tool to solve problems in mathematics and physics involving the area of an arbitrary shapes, the length of a curve, the volume of the solids, and among others. The rule in integration that corresponds to the product rule in differentiation is called integration by part. When we recall product rule, the formula are as shown as below. Integrate both sides of the equation will be as shown as below. Thus, we obtain the formula of integration by part is. It is usually convenient to write this formula using the following notation, which is u is equivalent to function f and v is equivalent to function g. Thus, The differentiation of u is the derivative of function f and the differentiation of v is the derivative of function g. By substitution rule, the above formula will become integral u times derivative of v equivalent to u times v minus integral v times derivative of u. We can use integration by part if substitution doesn't work. When applying integration by part, we have to make a suitable choice of u and the derivative of v. The new integral must be easier to evaluate and simpler than the original integral. There is some strategy in choosing u and the derivative of v. U is a function that can be differentiated, changed to simpler form, and derivative of v is a function that can be integrated. There is some priority in choosing u. I have a secret word which can be used to choose u easily, which is LP. L stands for logarithm, P stands for polynomial, E stands for exponential, T stands for trigonometric. So when you are choosing u, make sure you follow this LPAT order. Did you know this? Integration was used to design the Petronas Tower to making it stronger. Integration was widely used from sports to engineering to astronomy and space travel. Many differential equations were used in designing of the Sydney Opera House. So here we have question number 1, which stated that by using integration by part, find integral x times log x dx. So as we know the formula of integration by part and the priority of choosing u, hence let u be ln x and derivative of v is equivalent to x. When u equals to ln x, the derivative of u is 1 over x. When the derivative of v equals to x, thus to find v, we need to integrate x, which is equivalent to x squared over 2. Therefore, integral x times ln x dx is equivalent to x squared over 2 times ln x minus integral x squared over 2 times 1 over x dx. Here, the integration by part occurring on the right hand side, which is integral x squared over 2 times 1 over x dx. We need to solve the product of x squared over 2 and 1 over x first before we integrate. Hence, the following steps was: now we need to integrate x over 2 dx. Thus, we will obtain x squared over 2 ln x minus x squared over 4 plus c. We have question number 2. Question number 2 stated that show that integral x squared times exponential power negative x dx is equivalent to negative exponential power negative x times bracket x squared plus 2x plus 2 plus c. Let u equivalents to x power 2 and derivative of v equivalents to exponential power negative x. Then we will obtain derivative of u is 2x and v equivalents to negative exponential power negative x. By using the substitution rule, when we substitute into the original formula, we will obtain negative x squared times exponential power negative x plus 2 integral x times exponential power negative x dx. Here, first we will reduce to term of having the integral x times exponential power negative x dx from x squared times exponential power negative x dx, and then followed by the terms of having the integral of exponential power negative x dx. Since x times exponential power negative x dx is two different functions, thus we need to integrate by part again. Let u equivalents to x and the derivative of v is equivalent to exponential power negative x. Thus we obtain the du is equivalent to 1 and v is equivalent to negative exponential power negative x. When we substitute this into the original formula, we will obtain x times negative exponential power negative x minus integral of negative exponential power negative x times 1 dx. We will obtain negative x times exponential power negative x plus integral of exponential power negative x dx, followed by negative x times exponential power negative x plus bracket negative 1 times exponential power negative x, equivalent to negative x times exponential power negative x minus exponential power negative x. Therefore, integral x squared times exponential power negative x dx is equivalent to negative x power 2 times exponential power negative x plus 2 integral of x times exponential power negative x dx. Since we already find the integral x times exponential power negative x dx, which is equivalent to negative x times exponential power negative x minus exponential power negative x. Hence, we will substitute that into the formula. Thus, we will obtain negative x squared times exponential power negative x plus 2 bracket negative x times exponential power negative x minus exponential power negative x plus c. We will get negative x squared times exponential power negative x minus 2x times exponential power negative x minus 2 times exponential power negative x plus c. Since negative and exponential negative power x is common, hence we will obtain negative exponential power negative x times bracket x squared plus 2x plus 2 plus c. Let's see few examples of application of integration in daily life. Number 1. Indefinite integral was used to find the displacements from velocity and the velocity from the acceleration. Besides, integration was used to commuting the work done by varying force. Meanwhile, business today use several applications and require them to be integrated so that the business process as a whole perform seamlessly.